break even, to not make money and not to lose money. How would you do that?
420 divided by 10.5.
Okay, so but that you got from setting this equal to 0. Because when his profit is 0, that means he hasn't made any money, right? He hasn't lost money, but he hasn't made money. So if you set this equal to 0, you will wind up doing 420 divided by 1050. I saw a hand. No? How much money will he make if he does 20 jobs? What would you do there? If I ask you, what will his profit be if he does 20 jobs? What would you do? What's that? Plug it in for X. Yes, you'd replace that with 20. How many? 40. Is it 40? 40. Okay, we're going to move on because we don't have a lot of time left. Just please understand the difference between cost, revenue, and profit when the test comes. Let's just talk through this next one. I don't think we're going to work it out. In meteorology, the temperature is related to the altitude by this formula. So you have temperature is a function of H, and it's equal to negative 3.5 H plus 58.6, where H is something in thousands of feet. Altitude, oh, that's it. It's thousands of feet. Okay, so what's the slope? Identify and interpret the slope. The slope is negative 0.35, right? This represents your change in temperature. Okay, so as the altitude changes, the negative 3.5 means that as your altitude goes up, your temperature comes down. And then what is the 58.6? Oh, it doesn't ask for that. Never mind. Part B, what should the temperature be at a height of 1,200 feet? What are you going to do with that? 1,200, you plug it in for H. Okay? At what height will the temperature be 32 degrees Fahrenheit? Set this equal to 32. Okay? I'm not going to go through that work. All right, 15 minutes left, right? We are going to switch to something different now. These mixture problems. So let's read through this. Mixing 1 gallon of 100% apple juice with 1 gallon of water. How much total liquid results in what percent is juice? Apple juice. Okay, so let's just start with that first part. What do y'all think? Without doing any math. You have 1 gallon of 100% apple juice, and you mix it with 1 gallon of water. Mix them together. How many gallons will you have?
2 gallons.
2 gallons. What's the new concentration of apple juice in that 2 gallon mixture?
50%.
50%. Does that make sense to everyone? Okay. Now I'm going to do that same problem, even though we know the answer should be 50%. Right? I'm going to do it visually because as these get harder, it won't be that easy to do in your head. So let's say we have a container. I like to draw pictures for these. This is 1 gallon. And I'm going to put in here, it's 100% apple juice, right? Juice. And I'm going to add to that 1 gallon. What percent juice is in here? Well, it's water, right? So how much percent is juice? 0% juice, right? 0% juice. So if we're looking at this, is like this is all juice, right? It's all apple juice. This one has no apple juice in it. So when I add these together, right, I'm going to get 2 gallons, right? Yes? And you all said that it would be 50% mixture. So how do we get that mathematically? Let me show you. What we do is we take the 100% here and we multiply it times how much of it there was. So what's 100% rewritten as a decimal? What's 100% written as a decimal? 1, right? So we're going to take our 100% and we're going to multiply it by the quantity we had here, 1 gallon, all right? Which is really saying 1 times 1, which is 1. Does that make sense? I mean, just follow me for now, but I took that number, multiplied it by that number, and got an answer. Now over here, let's do the same thing. We have 0%, right? And we're going to multiply that times what? 1 gallon. But 0 converted to a decimal is still 0. 0 times 1 is still 0, right? So now what we're going to do to get our final percentage, which we know the answer should be 50%, right? Is we're going to take these two answers and add them up. Okay, so I'm going to take my 1, I'm going to add to it the 0, and then divide by, what do you think? The 2 here. Okay? So what this did is this actually figured out like how much of this stuff was juice? All of it. How much of this stuff was juice? None of it, right? Then it said, okay, how much juice do you have? So how much juice? And then this is the total, right? Total gallons. And so if I divide these two, right? 1 divided by 2, you get 0.5. And that's 50%. All right? Make sense? Okay, let's change it now. And let's do the same thing, but what if you mix 3 gallons of juice with 1 gallon of water? So what changes here? If I'm going to do the second part of this problem, what's the thing that's going to need to be it? That 1 gallon on the first one needs to be 3 gallons, right? So I come through here, I would change this to 3 gallons, right? This would stay the same. Over here, what would change? Now we have 4 gallons, not 2 gallons, right? All right. How about our computation, that stuff in red? Would that change? Yeah. That changes, right? Because this is now 100% times what? 3. 100% to a decimal times 3, that gives you 3, right? And then over here, does this change? No. So we have a 3 and we have a 0. We take those, we add those up. This becomes 3. And this becomes 4. And so now you have 3 over 4 instead of 1 over 2. And 3 over 4 is 0.75. So our mixture is 75% apple juice. Okay? Now let's do another one, because that first one is kind of basic. All right. If there is a mixture of 2 liters of 10% butterfat milk and 1 liter of skim milk, which has 0 butterfat, how many liters result in what is the percent of butterfat? Okay, so basically we're going to be talking about, this is like milk, okay? And when you say it's 10%, we're saying in that milk, 10% of it is fat. And if you're looking at skim milk, then you have no fat in that milk, right? So it's kind of like the juice, but talking about different substance. So I'm going to do it exactly the same way I just did the previous one. Here's my first container. Okay, how much does it contain? How much is in there? 2 liters. So I'm going to put 2L here, 2 liters. Okay, what is the concentration, the percentage in there? 10%, right? So 10% of this is, I'm just going to say fat for butter fat, okay? It's got 2 liter mixture, it's got 10% fat in it. I'm going to add to that another container that has, how much? 0%, but how much is in this? 1 liter? And what we want to know is how many liters result in what's the percent butterfat. So when we add these two together, how many liters do we have? 3 liters. That's the easy part, right? You just add up the liters. But what's the percent? So this is where you go do that little computation. So I'm going to take, let's see, where am I at here? Christine? Is Christine here? No? How about Becca? Becca. You understand what we did in the last one? Okay, so what's the computation I'm going to do from this one? 10. So 10% times 2. And then turn that into decimal, 0.1 times 2, right? And that should give you 0.2, all right? Now here, same thing, right? So 0% times 1, but that's not going to matter. It's going to be 0. Okay, Becca, what do you do over here with that? The total liters, that goes on the bottom. Okay, so that's our 3 liters on the bottom. 0.2 plus 0. Good. Right, so you take this number plus this number, put those on top, divided by our total liters. And that we might need a calculator for. 0.2 divided by 3. What is that? Approximately what? 0.6. Is that what I'm hearing? 666?
Keep going to 666.
6. No, we're going to stop at 666. Okay, right? Now, Becca, this is our answer, but it says, you know, how many liters result and what's the percent? So we want to convert this to a percent now, right? Move it 1, 2, right? So we'll just say 6.66%. 6.6% fat. Understand how this works? Okay, so something that would be interesting, more interesting than this, I think, would be like, I don't know what the percentage is in whole milk, but it's definitely more than 10%. You know, what if this was, let's say, like, it's weird. I think in all the years I've taught, that's never happened, that just flashes like that. It has to be this, right? Okay. So if this were 30%, you know, the only difference here, this would stay the same, right? This would become 0.3. Now this would contribute to it, right? And then when you add those together, you would get something else. Anyone who's ever taken like chemistry in high school or here, a lot of times when you have to have like a certain like acid solution, the chemistry like instructor will go to the back and they'll grab these 2 containers, and what they do is like one of them's like a 50% concentration, the other one's like a 10%, but maybe in the experiment you need a 20% mix concentration. So what they do is they do something like this and they say, okay, I'm going to add a little bit of this one and a little bit of that, stir it up, and they know that that's now 20%. Does that make sense? So you don't have to have like a jar of 20%, a jar of 15%, a jar of 10%. You can just have like a 50% and a 10% and pretty much make everything in between. Okay, good? All right, I think that should probably take us through the review. Let me see. On the review here, 12 gallons of pure water added to 5 gallons of 25% hydrochloric acid. How many gallons are in the mixture? I'm looking at number 7 on the review. What is the concentration of hydrochloric acid in the final mixture? So 7, we good? Okay. So on this review, since I've got 5 minutes, the first one, write the equation of the line that's perpendicular to a line. So there were some problems like that in your homework. I didn't do any of them in class though. I think I talked through them, but I didn't actually go through in detail. So make sure you know how to do that. How about number 2? How do you tell if those 2 lines are parallel or perpendicular or neither? You compare their slopes. What is the slope of the first line? 3/4, right? What is the slope of the second line? What is it? Is it -4/3? Yeah, it's, look, on the first line, is it y equals mx plus b?
Yes.
It is, right? Y equals mx plus b. On the second one, is it y equals mx plus b? It is not. You have to get that y by itself first. So that negative 4/3 x is actually going to go the other side, which makes it positive 4/3 x, and therefore it's not perpendicular, right? They're not the same. They're not, remember, to be perpendicular, they have to be flipped and change sign, right? So the answer to that would be neither. Okay, numbers 3, 4, and 5 are all problems where I ask you to graph a line. But notice I ask in the problems for you to write it in slope-intercept form. What am I asking you to do there? Write it in slope-intercept form. Solve for y. Okay, you have to solve for y. You have to find the x-intercept and y-intercept. I don't care how you do that. Find the x-intercept and y-intercept. You do that however you want. Okay? But then you have to draw it and you have to label it. So what I mean by labeling it is when you graph this, whatever your answers are, I expect to see a line. I expect to see that point and that point labeled. Okay, so if this is like 2, 0, and this one is, let's say, 4, 0, I expect to see those labeled on your graph. All right? And then, of course, you also have to write the equation of the line, too. All right? And so there's 3 problems. You can see, like, the first, like number 3, number 4, pretty straightforward. Number 5 involves fractions. So just be prepared to work with fractions. Number 6 is about today. So we have some information about Dan. This is kind of like the guy from earlier who was on a diet, right? There is something tricky about number 6. Does anyone see what's tricky about it? Read through that. Something about part B. Yeah, so in part B, it's saying how much will Dan weigh in 2 weeks? But everything that's given before this is talking about how much he loses per day, right? So in part B, you can't plug 2 into the function. You have to plug in 14. All right, so just be careful with things like that. Read it carefully. All right, and then 12 gallons of pure water, we just did that. And then on the back, refer to last class. Last class, I put a graph of a function up here, and we went around and tried to figure out, like, what are the values, and then when is the function equal to a certain thing. And then on number 9, this one, make sure you add that. And then you have the conversions. All right? Yeah, I don't know when I'm going to get to it, though. You know what I'll do? I'll offer a 5-point bonus to the first 3 people to post the solutions to this on Canvas in the discussion board. 5 points for the first 3 people who can post the solutions to this in Canvas. Now, I'll go look at them and make sure they're right, and then tell everyone, yeah, they're good. All right? So I'm going to offer it as a bonus for the solutions. Yes? Well, I mean, you need to have like a majority of them being right. Yeah. Okay, everyone, have a good weekend. See you Monday. All right, excuse me, sorry.